Hello, this is going to be a series about for my presentations for school. I just need a little bit more practice, so that's why I'm doing this. And I also need to get more comfortable speaking in front of a camera. So yeah, this one's about geometry, and it might be a little bit scuffed because I don't have a clicker. So let's just get started. So we have to define what justification and similarity first is in geometry. And similarity is basically when two figures have the same shape but not necessarily the same size. So we could see in this model here that these two shapes are both right triangles with the same overall shape, but one is bigger and one smaller. So these two are similar. And justification is how we can prove these two shapes are similar. And there are three main types of justification. So we have AA, SAS, and SSS. So first is angle, which we need two angles for, and we need to find the corresponding angles from each triangle. So I like to imagine flipping this triangle so that all the angles line up with each other and they're in the same orientation. So if we flip it, we can line up these two 80 and 80 degrees. So those two are corresponding angles and they're congruent. So that's one piece of the puzzle. And then to figure out what the angle of F is, we can do something called the triangle sum theorem, which basically is we add these two and subtract it from 180 because all triangles add up to 180. And we could find that the angle of F is 60 degrees. So these two line up at 60 degrees and they're both congruent. We can put those into a similarity statement here, and it's like basically a flow chart to prove that these two triangles are similar. So we have the measurement of angle A equals to F. We have the measurement of angle B equals to E, and then we have AA right here. Then they all connect to our overall statement that triangle ABC is equal to FED. So next is SAS, which is we need two proportional sides and an angle in between. So we can have them in the same orientation by flipping this triangle. So we have 50 lining up with 50 here. So these two are congruent. They're both overlapping, and we can figure out which sides correspond to each other by looking at the length of the sides. So these two sides are the longest, so 24 would correspond to 16, and 12 correspond to 8 because those two are in the middle in terms of length. And to figure out if these two sides are proportional, we would need to find something called a scale factor, which is how much one triangle is scaled up to another. So we would find that by dividing each of it by its counterpart. So 12 divided by 8 is 1.5, and 24 divided by 16 would be also 1.5. And then now we have both 1.5 here, so the scale factor is the same, and we know that these two triangles are similar because they have the same scale factor and the angle in the middle adds up. So we have our statement here, and then our overall statement that triangle ABC is similar to DFE. Alright, so last for our similarity statements is SSS, which is side, side, side. And we need to find three proportional sides, so like the last one, but without the extra angle in the middle. So we can match up the sides again, like the shortest sides, the longest sides, and then the sides in the middle. So once we divide all of that by their counterparts, I got 1.4 for all of them, so that means the scale factor is true for all of them, and it's similar. So this triangle is a scaled up version by 1.4 to that triangle, and these two triangles are similar. So we have a similarity statement and then our overstatement. Alright, so last is my test problem correction. And this is basically what I got wrong on the test and how I could fix it next time. So my scale factor was from DEF to ABC, so 2.3 or 2/3. However, it should have been from this triangle from on the left to DEF, so times 1.5. And up here, I corrected all my side measurements by the new scale factor instead of the old scale factor, which was from right to left. Alright, so that's just all for my presentation. I'll probably be uploading another one tomorrow, and thank you for watching.